Hey, Green. This prom is kind of boring. You're really kind of no fun. Really, Red? I think I'm a blast. Look at my ears. I'm so bored. I wish I came here with somebody else.
Well, look at my mustache. How could you say that? I am French. Mustaches always turn people on.
Well, it's not doing anything for me, Mr. Mustache. I wish there was someone else I came with. Ooh. Look at that guy over there with the curly hair.
What do you mean? He's got nothing on me.
Yeah, he's kind of got a cool curl on top of his head. Ooh, Mr. Green, did you see that really cute guy with the spiky hair? What? Spiky hair? I've got these awesome ears. No, I think I'm going to have to say I don't want to be with you anymore. You don't want to be with me anymore? No. I think I want to be with Mr. Spiky. We seem to make a better couple.
Well, what about us?
Yeah, I have no desire to be with Mr. Mustache over there. Well, you guys can do whatever you want. Well, I don't want to be with you.
Well, I don't want to be with you either.
You are not cute. Well, then let's just stand and do nothing. Ooh, now this is a great chemistry. Ooh, I love you. I love you too.
Well, what are we supposed to do?
Well, you can stand and watch if you want.
Maybe I will watch with my new eyeballs.
Well, maybe I will watch too because I don't want to dance with you. Okay, fine. Want to dance? I would love to. What is that, a disco ball? This is so much fun. I love you. I love you too. All right. What does this all mean? And is this really our flipped video? Yes, it is. We are actually learning about something called net ionic equations. And what you just saw is what happens in net ionic equations. So you have a couple that come to the dance and another couple that come to the dance, right? Double replacement reaction. Except now you get new couples forming, right? So I've got the rainbow happening, and I've got red and black together, and the other set of rainbow, the green and blue. But as you saw in our production, green and blue want nothing to do with each other. Red and black really like each other. So in this example, red and black represent our solid, our precipitate. Our green and blue are what we label as aqueous. So how does this all work out? What do we do in a net ionic equation? Well, what a net ionic equation shows us is it shows only the ions that actually take part in a reaction. And the ions that take part in a reaction were these two that formed a solid. So the solid formed the precipitate. And that's our new product that we made. This is our new chemistry, our love. So what happened with these two? Well, aqueous substances actually never form a precipitate, so they don't come together. They actually split into their ions. So this is misleading right now. Really, they should be apart from each other, aqueous and aqueous. Okay, they're not connected, and we call them spectator ions. That's why they got the eyeballs, right? They got these eyeballs because all they do is they watch what's happening in the beaker. I mean, not really, but we call them spectator ions. They don't participate. And the love seen here, as I like to call it, is the new solid that gets formed. So this is what we concentrate on, the solid. These are just dissolved ions. Okay, so let's take a look at a real reaction and figure out how to do this. Okay, so here we are with calcium nitrate and potassium sulfate. If we predict these products, we get the following. Outside with outside and inside with inside. So we get CaSO4 and KNO3. We need to know their states of matter And then we have to also balance them. So let me balance this. Looks like it should do. Okay, and our states of matter. So now it's time to pull out our solubility rules. Remember, this is just double replacement. So net ionic equations are used for double replacement. And what we're going to do in a net ionic is show what's actually happening in the beaker. Because so far we've been thinking everything happens, and it does, but what's important? So when I look these up on my solubility sheet, hopefully you've looked up the rules. My solid is this one right here, because I know all nitrates are aqueous. So this is my precipitate. This is insoluble. This is the focus. What happens here? These turn into spectator ions. They break apart. So let's take a look at what this looks like in the beaker before we write a net ionic equation. Okay, so if this is my beaker, right here, okay, and here are my ions, I've got these two being dumped into my beaker, calcium nitrate and K2SO4. They're dumped in my beaker. As soon as these are dumped in my beaker, they break apart into their ions. So here is calcium and nitrates breaking up into their ions. That's the calcium nitrate part. And here's the other reactant, potassium and sulfate breaking into their ions. 2 potassiums for every 1 sulfate. Everyone breaks into their ions. So everybody breaks apart at the dance, right? At prom, everyone breaks apart. And now new love is found in the beaker. So some people actually come together and make this new love, whereas others say, I don't even want anything to do with this, and I'm just going to stand on the wall and spectate. So who does what? The solid always comes together and makes our newfound love, whereas our aqueous just stands as spectator ions. They don't actually come together in the beaker. So what ends up happening then is my calcium and my sulfate find each other and make new love, right? And make a new partnership down there. And so they're together as a compound, the solid precipitate. And my potassium and nitrates, they never come together. They just float around the beaker as spectator ions. So as you notice, we've got our new love made down there, and we've got some other spectator ions. Okay? So a net ionic reaction actually shows, what's coming together to make our newfound love. So if we remember from here, our most important thing is our solid. So I transfer that down here, CaSO4 solid. And our net ionic shows which ions, so on this part it's the ions that came together and found our new love. So that was the calcium and the sulfate ion found here, the calcium and the sulfate ion. So I look back on my periodic table, notice calcium's 2+. It's aqueous since it's split up in the beaker. And my sulfate, so plus, my sulfate ion was 2-. It's also aqueous. My ions are always aqueous, break apart. And they came together. When they came together, they made the solid. So it's ions making the solid product. That is what a net ionic equation shows. It shows net, what nets in the beaker, what you make in the beaker. And this is our new love. Notice nowhere in here do I say anything about KNO3, because KNO3 does not make our new substance. So KNO3, nothing about KNO3 is included in a net ionic equation. So let's look at another example. Here we have lead, probably fill this in, lead 2 nitrate and sodium sulfate. So if we predict these products here, we get lead and sulfate coming together. So we have PbSO4. Remember, lead has a charge of 2+, sulfate has 2-. And sodium and nitrate. Na has a charge of +1, nitrate has a charge of -1. Let's write their states of matter. Remember, all reactants in a double replacement are aqueous. I look on my solubility chart for my rules, and I remember all nitrates are aqueous. They are soluble. And I look up lead 2 sulfate. I look up lead or sulfate, and I notice that this forms into the solid known as the precipitate. Now I want to write my net ionic equation. So what really happened in this beaker? Here's what happened. These two came to the dance, and they broke up. So now I've got a bunch of Pb2 plus, NO3 minus, Na2, or oops, just Na plus, and SO4 2 minus hanging out in my beaker. They swim around, and if you notice, the Pb and the SO4 find each other and precipitate out, meaning they make a solid, whereas the Na and the NO3 stay as spectator ions. I know this because of my solubility rules. Aqueous turns into ions, spectator ions. Solid means a precipitate formed, meaning they came together to make the solid. So when I want to write the net, I show what helped make the precipitate. So I copy the solid precipitate that got formed on this side. And then over on this side, I say, what were the ions? What were the ions that helped make this? So the ions that helped make this came from the Pb2 plus. Don't forget, my ions are aqueous. Plus the SO4 2 minus, also aqueous. Okay. Let's make sure we've got everything balanced. Looks like we did. Let's check back up here. I needed to balance this. And I think that that's good. Okay, all done. That's the end of this flip video.